Hi, welcome to our cloud computing course. We will continue our discussion on initially on basic or foundation of this cloud computing and then go into the more detail. So, as we were discussing yesterday or in the last class rather that NIST defined cloud computing, how NIST defined the cloud computing model as enabling ubiquitous, convenient, on demand network access to a shared pool of configurable computing resources. This is a point to be noted. So, that means there is a shared pool of resource which can be configured as per demand. So, that can be rapidly provisioned, that means it can be provisioned to realize something and released, or when I do not require it can be released with minimal management effort or service provider interaction. That means, whenever a customer or the user or the service consumer needs, it can provision. Whenever it does not, the no requirement is there, it can deprovision it, and that is exactly the pay as you go model. If we look at the essential characteristics, as we have already seen some of the things, like what we require, it is a on demand self service, that is a service which is on demand, and it is a on demand self service. Broad network access, this is important thing, that means I should have a appropriate network access, because resources are distributed, they are at different geographical location, they are being pooled and provisioned to the user. There is another thing is the resource pooling, that means I can basically pool resources into the for my needs, and that gives us a multi tenant model with different physical and virtual resource dynamically assigned. Like I from the same service provider, I want to have a say Windows system, Windows subsystem with so many hardware specification, and these are the different software specification. From the same service provider, somebody is having say a Linux, say Ubuntu subsystem, and want to realize those resources on the things. So, this sort of resource pooling and management of the resources is important aspects of the thing. There is another characteristics, any type of services are measured services, right. That means I pay for what I use. So, whatever I am using is being measured. So, this is a measured services, and another important aspects is rapid elasticity. That means I can go up, down as and when requirement is there. Like if I take a example, like I am running a simulation and I need a something a 4 GB sort of RAM, and when it is when while running the things more data comes or more application load is there, I want to increase the RAM to 4 GB to 8 GB, right. So, I need to for some portion of the time I need to have a bring more resources. So, that should I will be able to rapidly provision it, and not only that, this type of elasticity should be there. So, it should be I can go up, come down when I requirement is there. So, that should be one of the important characteristics or property of cloud. There are several common characteristics which are what we say that typically a cloud computing platform or cloud service provider should provide. One is, as we have discussed, massive scale up and down, resilient computing, homogeneity, like I do not care that how whether at the back end that heterogeneous resources are there, I want to have a homogeneous thing. Typical one characteristics is that they are usually the resources may be geographically spread or geographic distribution. One major aspect is virtualization. So, I virtualize the thing. So, I virtualize a Windows over a Linux, say there is that sort of thing, or I have a infrastructure over that I virtualize several virtual machines and work on it. I can have different virtual applications I work on it and type of things. So, that is one important aspect. Rather in subsequent lectures we will look little bit more on this virtualization aspect. There is a important aspect of service orientation. So, it is the services which are being communicating with each other, rather than it is a data driven. So, it is not data orientation, more of a service orientation. There can be different type of services. So, if we will see that in a service oriented architecture, so like we can have a service service provider, there can be a service consumer, and there is a registry service or what we say somewhere some catalog. So, the consumer talks to the or look up to the registry and find that what are the services that they are appropriately collect to the provider to access this service, right. And service provider, whenever it is having more, or this is different service provider, it is a basically a bunch of represent a bunch of service providers, bunch of consumer, and it is a distributed, but some of logically centralized registry or catalog, and this service provider with basically upload update the registry in the things. It is as if I can have an analogy like this is a telephone directory type of thing, where I have different type of yellow pages and other things, and if whenever I require something to search starting from a particular person to particular type of activity, like I want to look for a say home delivery services. So, I look at the things that who are the home delivery services and then connect to that thing by the telephone call, right. So, this is somewhere a catalog or registry, service provider and consumer. This overall it is a some sort of a service oriented architecture, right. So, that will again we will see little bit more that what are the different type of service oriented architecture. So, one of the major aspects of this cloud computing is to realize service oriented architecture. There is it usually have a low cost software, in the sense like as this is being used and it is a multi-tenant type of things, the overall costing of the software comes down for the consumer end, right, and expected to give a advanced security. There are different concern about security, we will discuss some of the things, but expect to have a concern about the security. It is not only security in terms of whether somebody is breaching the security on things, some of the things like I say that if the data is in cloud, there is expected that the data is not lost, right, but if it is it is in my own system. So, it is my responsibility to save the system, keep the system up and things. Similarly, some application I am say a mail application on the cloud. So, it is expected that this is more stable and type of things, whereas if I am having my own mail server and mail relay etc., then it is my maintenance and it goes on the things. So, there are different aspects of the things. So, it is like it is supposed to provide advanced security features with respect to access control, with respect to different resilient or blocking of different attacks, with respect to data preservation or no data loss type of situation and type of things, right. So, if we look at the typical cloud service model, we will go into more details subsequently. So, one as we immediately look at it is the software as a service, right. So, what we see the capability to provide consumer to use providers application running on cloud infrastructure, like we are nowadays using different type of things, different type of aspects like say word processing, a spreadsheet on the internet, right. Even there are different, if you those who are used to scientific technical writing etc., using tools like LaTeX etc., we are having things called which are on the web. So, that means those applications are somewhere else on the cloud, and we want to hook into that application and then use those application and get my data either stored in my own local machine, or at times the data is stored in some other data service provider, right. So, that means what you require is a basic minimal way of interfacing to the external cloud, right, and gets that the software as a service. Now, the softwares must be running as some system or must be compiling or compiled on some platform. As a user, I am not bothered about it, right. What I say that for using the system, what I require a basic interface, maybe some sort of a web browser like say Mozilla, Internet Explorer, Chrome and etc., etc. So, and I have a basic and I have the knowledge to how to use the software. It can be a word processor, it can be a scientific simulator, it can be a text processing, it can be a some other type of applications like a mathematical application or type of things. So, so this is as a software as a service. So, what I am getting, the service I am getting as a software, so that makes lot of convenience at my end. I do not have to purchase that software, neither I have to maintain the updates, neither I have to look at that how much my hardware requirement to run the software. In some of the software there may be hardware requirement much higher, but my application is not that large. So, so that scaling of the software becomes the responsibility. So, this is a software as a service. Another thing is that infrastructure as a service. So, that means I want to realize some infrastructure at my end, right. So, that is the infrastructure as a service. Like I want to realize a machine of particular specification, like I say it should have some 4 GB RAM, so much megahertz processor and so much hard disk, right. So, this is a infrastructure, as if I am realizing the whole system on my desk, right. So, that if I can have different a simple system and I can basically have this infrastructure as service. Today I require a 4 GB RAM, tomorrow I require a 64 GB RAM for some work, next day I require a 2 GB RAM, I want to only do some basic operation. So, usually when I have this type of variable requirements or type of things, I can basically provision that the infrastructure. So, there are provider who provides infrastructure as a service, right. In between these two, IaaS, infrastructure as a service, and software as a service, we have another stuff called platform as a service, right. So, it provides a platform for some development work, some using some test cases and other things. So, I require, so one is that software I am using, another thing is that I have the infrastructure, I load OS, or the OS can come with the infrastructure, I load other applications, then run and test and other things. Otherwise, I require the platform as a service, right. So, there are service provider who provide platform as a service type of models. So, this allows me to use as a platform. So, these are three very prominent what we say service model of cloud. There are other various service model, rather like data as a service which keep the data. Even people are talking about whether I can have something like science as a service, like I give different scientific tools etc., and then you work on a particular avenue on the type of things and looking at the things, or what we say it is a anything as a service or XaaS type of things. A typical cloud philosophy wants to make this XaaS a realization, anything as a service type of model. So, if we look at this overall stack, so what we have at the below is the basic infrastructure, this is, and over that this is platform as a service, and over there are software as a services, right. And there can be different type of infrastructure, like we can say that virtual machine may be one infrastructure, servers, storage, load balancer, network, these are the different type of infrastructures, right. And there can be different other type of infrastructure as you can feel. So, I can have external devices and other things as a infrastructure and type of things which can be pulled in. Over that, when we look at the platform as a service, that is more of a something execution platform on runtime, databases, web server, development tool, development platform, there can be some sort of a sandbox type of environment and type of things. So, these are more as a platform as a service, and over that I have a SaaS or the software as a service which basically realize the this softwares, like there can be CRM, email, different virtual desktop, there are different games and so on things which runs over and above this cloud infrastructure and PaaS. Now, so this part is more of the cloud provider end. So, some provider may provide SaaS, some may provide PaaS, some may provide SaaS, IaaS or what we say infrastructure as a service, some may provide a mix of the things, right. But if we look at the client perspective, so how client access it? So, the best or the what we say the universal way is the web browser, right, or what we say web client. There are other things like I can have mobile apps, right, which can access this type of thing. Even there are thin clients, the terminal emulator and different type of other things. So, these are the interface by which the client interface to this cloud, right. Now, if we with this thing, if we want to look at the different type of deployment models, right. So, what are the different type of deployment, how to realize those cloud or type of clouds, right. One is the private cloud, I build a cloud and I use it, like in our IIT Kharagpur with indigenously with open source systems, we build a cloud called Meghmala. So, it is name of the cloud is Meghmala, it is a very not so large cloud, but it is privately built on open source system, primarily used by researchers, both faculty and research scholars, for mostly a infrastructure as a service over the things. Over that we try to give other services like data services or other type of big data services and type of things, but primarily it is a infrastructure as a service. So, it is a private cloud, it is accessible within IIT Kharagpur network itself and not accessible outside the network, right. And it has a different charging model, like as it is a institute funded infrastructure. So, we do not charge anything on things. There can be other end a what we say public cloud, right. So, that means which is public. So, at different type of things, I can have public clouds as infrastructure, I can have private clouds as like Amazon clouds are for infrastructure, for one of the popular example. There can be platform as a service type of cloud, like what we look at some sort of a what we say that Microsoft Azure, or we can have things like software as a service type of cloud, like Google Docs, Google Spreadsheet type of things, some of the examples. So, these are the public clouds, right. There are another things where I can have a hybrid cloud, right. So, it is a mix of things of public and private as such. There is a typical category of cloud which is a what we say community cloud. So, it is something semi public, semi private type of things, like I can have it is shared by several organization and support specific goals, or what we say quote unquote it is a some sort of a like minded or like means same type of goal achieving organization, like I say bank sector may have a banking cloud, right. So, that core banking things whatever they exchange with the things in our country, like RBI may be the nodal agency to handle all the things, over that there is a cloud. I can have a institutional cloud, like what we say government funded institutional cloud which can work on the things. I can have there are things like if I working with some other type of data like bank etc., like one like what we work on in the spatial data, we can have a geospatial cloud which with type of things. So, this is addressed to a community, may not be not in a one organization, multiple organization, but it has some purpose to do, right. So, this is a community cloud. Now, I can have a hybrid of the things, some private, some public, some community, or public private only and type of things, right. So, these are the different type of what we say deployment models of the cloud. Now, though we will go little more deeper into the things in subsequent lectures, but we want to see that the cloud and this virtualization somewhat come hand in hand, right. So, if we look at this picture which we say that virtualized or virtualization stack. So, we have a bare metal or the hardware at the end, right. Over that I require something a middleware which allows me to create different virtual things. So, what we are trying to see, like what we are saying that we are having different hardware, right. It can be different systems across different network etc., and connected through different sort of network etc. Over that what my end goal is to realize different virtual machine, like I can say this is a 16 GB machine of running Windows, this is a maybe 64 GB machine RAM with running something some variant of Linux etc., right. Now, this collectively being realized to make this type of different virtual machines, right. So, I require something in between what we say VMM or virtual machine monitor or hypervisor. So, this hypervisor basically allows me to emulate these different type of machines. So, if we look at the virtualization stack, so one or virtualization how I want to, what we want to virtualize. One is that virtual workspaces. I can have different virtual workspaces, an abstraction of an execution environment that can be made dynamically available to the authorized clients by using well defined protocol. So, I suppose for my particular project I require a environment for this, maybe development environment, visualization environment, computing environment, and then I generate dynamically, or the organization generate dynamically to the, for the team to work on it, right. And that may be a short term project of 14 days or something, and it basically realized. Purchasing a whole stuff for that 14 days may be a costly affair, but if I provision that from external world on a pay you or from public cloud, and maybe a solution, right. So, there is one another thing aspect is the virtual machine. I want to realize into different virtual machines, and then there can be different category of virtual machines which can be used by the user. Like as we are talking about Meghmala, we realize different category of virtual machines with basically 3 category of virtual machines, and whenever user needs come, we provision it based on the availability of the things. And it can provide infrastructure API, plugins to hardware, support infrastructure, etc. So, it provides API to connect to the different infrastructure. So, we will basically look at virtualization. There are different aspects of virtualization, so that we will look at in the subsequent lectures. So, if we just look at this whatever we are talking about, so virtual machine technology allows multiple virtual machine to run on a single physical machine. So, this is my hardware. So, it is not that single physical machine means not only one machine, there can be couple of machine clubbed together and realize. Like I say that I have 10 4 GB systems, or so that I can have some effectively 40 GB things, and then I realize say 3 or 2 16 GB and 1 8 GB. Actually, you cannot do all division. There are some requirement to for this virtualization to happen. So, it 40 GB can be break into 2 16 GB, and so I realize 2 16 GB machine using underlining this hardware, right. So, what we require is, one is the virtual machine monitor, which allows me to emulate this hardware, and I can have different virtual machines over the things. And there are a concept of gateways which resides on the things, right. So, there are the gateways here, maybe Linux, there can be other gateways, there can be other gateways, and different type of things. And these applications running on the things are different, and this virtual machine may be used by somebody at some geographical location, this virtual machine somebody at some other geographical location, and so on and so forth. So, everybody for individual consumer, it is a machine for its purpose. So, there are different category of virtualization. We will see the things like performance para virtualization, close to raw physical performance. We will see that why and how and later on. So, some of the popular virtual machine monitor or hypervisor is, one is Xen, another is VMware. So, virtualization in general, there are advantages of the virtual machines, like run operating system where the physical hardware is unavailable, easier to create new machine, backup machine, etc. Software testing using clean install, etc. There are number of things which can be realized with this virtual machine. So, there are issues of cloud sourcing when we are, why it is becoming important. First of all, high scale low cost providers. So, I can have lot of resources as a thing. So, economy part play a important role, right, when you get much cheaper services on the things, etc. We will see in a separate lecture that whether this economy is always what this cloud economics of cloud says, and whether always it is a beneficial, or we need to think about that when the things are beneficial, etc. Anytime, any place access via web browser. So, it is my whole computing, my whole services, whatever I am accessing is anytime, any place type of services, right. So, I do not bother about that where the services are leveraged and type of things. And there are rapid scalability, incremental cost and load sharing. So, there is a scalability is pretty high, right. I can rapidly scalable. That is can't forget need to focus on local ITs, so that the whatever your infrastructure is there, that need to be looked into. There are some of the serious concerns also whenever you are leveraging all resources from the things. One major concern is performance, reliability and service level agreements, right. What will be the performance, what will be the reliability, the service is always on and type of things, and there are issues of service level agreements, like I sign some agreement with the things, whether those are honored, not honored and type of things. There are issues of concern of data and service parameters, like I say concern of the data, my data is in cloud, even I write a letter, the letter is in the cloud, I write a report that is in the cloud, then I am concerned that whether this data is secured, should not be tampered and so forth. And another issue is that service parameters is also there, like how to, they say that the availability is 90% or 95%. How to look at those parameters, how to audit that whatever I looked for is given by the things, right. There are issues of application features and choices. So, it's sometimes we say that it provides a application which is fits all, right, whether I do not have a customized choice of the thing, whether there are issues that whether I can have or not. There are issues of interaction between cloud providers, right. So, there are one provider purchasing services from the thing, like it may be a infrastructure provider purchasing some of the infrastructure like hardware etc., from a data provider and so on and so forth. No standard or like issue of standardization of the APIs, like whether it is a SOAP or REST type of services when we look at the service oriented architecture, and of course, issues of security, privacy, security, compliance, trust, competence, risk, these are the major concern whenever we purchase this sort of a service. Especially it is critical when we purchase those things for our some of the mission critical or my day to day operational requirement. Cloud storage, why we keep it separate, because it plays a pretty important role. We will, if time permits, we will look at that some of the storage aspects, but it's a one of the important factor, because data is extremely important for the consumer or for the service consumer or the users, right. So, allow data stored remotely to be temporarily cached on the desktop computers, mobile phones or other internet link device. So, you can have a syncing with that data also. Many of us are using this sort of services for putting our data as a service. So, there are things like Amazon EC2, SS3 are well known examples where these data services are there. Some of the advantages, just to reiterate, one is the lower computer cost, right. One major aspects that is low, I should say not computer cost, lower computing cost. Improved performance, I expect that the overall performance will be improved, because I am purchasing something as a higher price. Reduce software cost, like I do not have to purchase separate software etc. Instant software updates, if there is a update, it is getting updated. Improve document format compatibility, if there are interoperability issues, will be better addressed. Unlimited, theoretically unlimited storage, I pay and I get the storage. Increased data reliability, it is stored in distributed things with proper redundancy etc. So, it is expected the data relatively high. Universal information access, I can access information at every point. Latest version of the systems and software available. Easier group collaboration when we are having one data different applications. Device independent, I can access from different type of devices. Requires there are obviously some, these are all good points, there are always some pitfalls or some concerns or disadvantages, like requires a constant internet connection, you are disconnected, you are gone. Does not work well with low speed connection, that is again network connectivity. Feature might be limited, right. So, some of the things I may not get what I get on a customized personal thing, it can be slow at time, because this provisioning etc. finally takes time. Stored data, we are really concerned about whether how secure it is. Stored data can be lost if there is a crash on the things or the provider goes out of the things, there may be a chance of loss. cloud is not truly a high performance computing system. So, if we think that cloud will provide high performance, so it may not provide that HPC type of things, and there are several general concept of connectivity of APIs, having particular database connectivity, where the database will run, etc. So, what we will do, we will stop here and for now, and then we will look at the different architecture and in our subsequent lectures. Thank you.